For this video, I'll be discussing the methods and models used for multiple sclerosis, using the paper by Claudio Protochini called Animal Models of Multiple Sclerosis. The three animal models of MS that this paper goes over are the experimental autoimmune encephalomyelitis, or EAE, the virally induced chronic demyelinating disease known as the Thylacinurine encephalomyelitis virus, or TMEV, infection, and the toxin-induced demyelination. To start, EAE serves as a model that closely mirrors the autoimmune processes underlying MS, making it exceptionally valuable for studying potential experimental treatments for the condition. So, what is it? Experimental autoimmune encephalomyelitis, EAE, is an animal model of T-cell-mediated CNS demyelination. EAE can be induced in mice with various genetic backgrounds like SJLJ, C57BL6, and NOD. They can be initiated by the CD4+, which are MCH2 restricted for helper functions, or CD8 T cells for MCH1 restricted for cytotoxic functions. Here, I want to compare the differences in relapsing remitting, or RR, and CH, or chronic EAE models. Each model uses a different CNS protein, the proteolipid protein, PLP, a major myelin protein not expressed in oligodendrocytes, only myelin, and the myelin oligodendrocyte glycoprotein, MOG, present on the membrane of oligodendrocytes as immunogens. The SJLJ mice immunized with PLP exhibited relapsing remitting disease scores. In contrast, the disease induced by the MOG peptide in C57BL6J mice is characterized by a chronic nature. The application of both is to study the neuroinflammation and the immune system activation. Ultimately, the study found that the CH-EAE model is characterized by greater myelin loss, an increase in CD8 T+ cells, and with an increased lesion burden in comparison to the relapsing remitting EAE. In the next video, we'll be able to discuss the therapeutic applications of this MS model. Demyelination can be induced in mice by viral infections of the CNS. Amongst the studied viruses is Thylacinurine encephalomyelitis virus. TMEV is classified as a non-enveloped, positive-sense, single-stranded RNA virus and stands out as a neurotropic viral infection model relevant to multiple sclerosis. TMEV is divided into two subgroups, GDV2 and TO, with distinct neurovirulent characteristics. The GDV2 subgroup is characterized as inducing death of mice within 1 to 2 weeks, whereas the TO subgroup induces acute polioencephalomyelitis. In multiple sclerosis and EAE, axonal damage is seen as a consequence of severe inflammatory demyelination following an outside-in model. However, in the TMEV infection, axonal damage precedes demyelination, forming an inside-out model. The TMEV model mirrors MS clinical manifestation, is confined to mice, and lacks direct relevance to human pathology. Nonetheless, the TMEV model provides insights into immune activation, neuropathogenesis, and potential therapeutic avenues. While EAE is the most commonly used model, toxic models for demyelination prove to be well suited for investigating the processes of both de- and remyelination. There are two distinct agents used for this, cuprizone and lysocithin. Cuprizone, a copper chelating reagent, induces demyelination by targeting mature oligodendrocytes. This process, marked by oligodendrocyte apoptosis, stems from copper deficiency and mitochondrial disturbances. Lysocithin, an activator of phospholipase A2, triggers focal demyelination upon injection into the spinal cord. The acute phase following the injection, lesion sites are infiltrated with immune cells, fostering a unique environment for CNS repair. It's crucial to note that toxin-induced demyelination models, unlike EAE and virus-induced models, don't precisely mirror MS. Instead, they serve as established systems to delve into the intricate processes of de- and remyelination. Each of the three models has its limitations. The EAE model offers limited insights into MS progression. The virus-induced model is limited to mice, and the toxic-induced model isn't an MS model, but rather a model for de- and remyelination. Overall, however, the EAE model is most commonly used due to it being autoimmune.